a lot of predictive power. And that's why it's pretty standard in health economic surveys to ask this. There could be biases, we have to be concerned about them, but it is picking up something meaningful. People kind of understand their own health better than some of the objective data can always measure it. So it's a very standard question to use. What is your health stats? How healthy are you in general? Very healthy, somewhat healthy, not healthy? Okay, yeah, go ahead. Yeah. What do they typically say? People have a lot of fever. So fever and or malaria. So there's a kind of unfortunate thing, which in this part of Kenya, when people use the word for malaria and fever, it's almost interchangeable. And that's because people often don't know if their fever is a malarial fever or a non-malarial fever. But fever would be the most important one. Yeah?
So why you make comparison within a group? Just group one before treatment and after treatment, if that cross group.
Yeah, so what are people's reactions to that? So you're proposing what's called, let me just erase this top part, what's called a first differencing design. Or sometimes called a pre-post design. Why might we be concerned? So I think what you're proposing is saying, look, let's look at the difference, the average, let's use this bar to be average, of y for t equals 1 at baseline, at follow-up, minus the average of this outcome for the treated at baseline. That's what you're proposing. Like, just look at the difference over time for that group. What are the advantages of this estimator? I kind of just skipped over this estimator. This is a lot of people's initial reaction, pre-post, before, after. We've all seen those pictures in magazines, before the plastic surgery, after the plastic, Like before they're scowling and after they're really happy. Why not just do pre-post? What's the advantage of pre-post? What's the disadvantage of pre-post? Yeah, just the same people. That's nice. Okay, that could be one concern. It's a smaller slice, but I'm speaking for Elizabeth Terra. So what are some of the concerns with the school-age population? So if we took kids in 98 and 99 and just look at their differences in the treatment group, what else is changing for these kids over the course of that year that might make it hard to compare pre-post?
Everything in their life that you need to have control really fast.
So they go from being 9 years old to 10 years old. So they're taller, they're changing, they're learning lots of stuff. And I think, going back to the point, it's very attractive. They're the same people. We don't have to worry about comparing different people, apples to apples. The problem is a 9-year-old to a 10-year-old changes in so many ways that we don't want to attribute all of those changes just to deworming. Because we think all these other things are changing. Think of yourself, if you were to compare your freshman year to senior year in college, and maybe we'd give you deworming freshman year. We wouldn't want to say deworming was the only reason you learned all those great things you learned in college. Lots of other stuff is changing. What about another issue of timing? Beyond the fact that you're changing, you're getting older, everything else is just changing. What else is a timing issue that matters? Okay, so there's people have raised the issue of seasonality before, but then beyond just seasonality, maybe there was a flood, like a one-time event. So seasonality sort of suggests that year to year there's a certain pattern in outcomes. So if you look at U.S. consumer spending, it goes up every year in December because of Christmas. And but at the same time, so that's sort of a seasonality issue, or else there could be a one-time event, a very big one-time event. The advantage of comparing group 1 to group 2, they live in the same area, schools are all mixed in around each other, they're all going to be hit by that one-time event. So when you compare group 1 to group 2, that one-time event of the seasonality is sort of pushing them all in the same way. There's no reason they would differ. So that's the real attraction of comparing across groups rather than over time. Yeah? We do it. So in the paper, what we do is we pool the data for 98 and 99. So effectively, the estimator we're using is combining changes over time and differences across groups. So for instance, when group 2 switches status, we're taking into account where it started and where it ended up. For what I'm going to show you today, we're going to do more of these pure, basically follow-up comparisons. But in the paper, we use all the information. So all the information takes into account that maybe there were some baseline differences. In a few weeks, when we get to difference and difference analysis, we're going to get exactly this. In a difference and difference, you're taking into account changes over time as well as baseline differences. But we'll get there in a few weeks. Okay, what else do we look at? There's some suggested evidence of improvements in height for age. This again is a normalized score. The normalized so-called Z-score, basically there's standardized height and weight distributions for kids of all different ages, really by month. And those were based on standard anthropometrics, or standard body size, for American kids. So what the negative side means here is these primary school age kids in Kenya, on average, are about 1 standard deviation smaller than the typical American kid. And we would usually think of that as being a result of undernutrition. So in poor countries, kids tend to be smaller than American kids. And as countries get richer, they tend to usually approach the size of American kids because undernutrition is a big part, as well as the impact of disease when kids are young. So kids come down with lots of infections, they're not going to grow as well. And then we also collected finger prick blood draws to get hemoglobin. This is not a statistically significant difference, but it's going in the same direction of saying that kids have slightly better hemoglobin in group 1, in the treatment group. Yeah?
Here's the significance of height for age.
Yeah.
Why would you use why do you have their score?
In theory, yes. In theory, yes. If the worms are no longer pouring into your intestines, eating your food, and all that kind of stuff, you could grow more. Yikes. It's sort of falling this thing. It's kind of broken. So that's part of it. I will say that we've done longer-term follow-ups on the same kids. So this was the result in the initial paper. When we've done longer-term follow-ups on these kids, we don't get statistically significant height gains. Now, I don't know if that's because when group 2 and group 3 eventually got phased in, they also experienced some growth, or if this was sort of a spurious finding. I'm not sure. Being spurious meaning one we don't have very much confidence in. But that's what came through in the original data. Yeah, it would really be because of the improved nutrition from eliminating the worms. Oh, yep.
What's the typical time frame for actually being able to affect height? I don't think that 1 year is not. I think the weight would be more impactful.
Yeah, that's one of the funny things about these results, too, is that you might think weight would respond first. We don't find weight gains. And these kids are also a little bit old to experience height gains. The usual thinking is kids in the first 3 years of life, if you improve their nutrition and the disease environment, will grow a lot more. But after that, your vertical growth will not be as responsive to nutrition. That's kind of the conventional wisdom. So it is a little bit surprising that we found it. And I think the fact that when we do the long-term follow-up, these results are smaller and not quite significant and whatnot, means I have less confidence in the height finding than some of the other findings. Yeah? Yeah, that's another surprising thing. We don't find more of the height gains among the younger kids where you'd expect them. So there's a number of things here which says, look, if you look at a bunch of outcomes, you might find results that are kind of significant by chance, potentially. But anyway, this is what we found in the data for this measure. I don't have as much confidence in it. Yeah, is your hand up? Oh, I forget. In the paper, we work out what it is. It depends on the age of the kid, because the standard deviation means different things at different ages. But I think in the paper in a footnote, we say that, this corresponds to half a centimeter or whatever it is, some small amount of height gain. Okay, it's pretty small, right? It's basically 0.1 of the standard deviation. So, great. Okay, we talked about direct treatment effects. I focused on health and nutrition so far, because I really just want to get into the different methodologies of estimating treatment effects. I want to do that now with externalities in play. Then in the next lecture, we're going to go back to looking at treatment effects on education, which is one of the main goals of the study, to understand how health improvements affect education. So what I want to look at next is within school externality estimates. So what do I mean by within school externalities? What that means is comparing outcomes for kids in treatment schools who got treated and didn't get treated. We'll talk about what we can say there. Okay, so if we break out that that infection rate, which was whatever, 27 percentage points, and we compare what the infection rate was among those who took deworming, like when we had the name list, and on the day of treatment, we kept track of who took deworming, compare the kids who took deworming, those who were treated, to the kids in group 1 who did not take deworming. These are what the infection rates look like. So look at this for a second. Is this kind of the pattern you would expect? And how can we interpret some of these differences? So the difference between the treated and the untreated, yeah, go ahead.
Well, I was thinking, first I was thinking the difference, but think about it, the infection rate is 6 months. You guys asked the question, 6 months of drug use, so it's not like it drug gets rid of, the worms inside, but it doesn't prevent infection, so they're going to the same school. I expect the infection to be all the same.
So you're not too surprised that the treated and the untreated look kind of similar. They're only different by 10 points. What are some other people's reactions to that difference? So there's two ways of viewing this. If we don't think of a world with externalities, we just think all that matters is taking the drug, then we would kind of expect the untreated in group 1, everything else equal, to have an infection rate that looks a little more like group 2. Because in group 2, almost nobody took the drug. We would kind of say, well, these untreated should kind of look like group 2. But they don't. They have much lower infection. You have 52 to 34. At the same time, once we're comparing the people who chose to get treated to those who chose not to get treated, we're out of our experimental world now. People are selecting into getting treated, maybe based on their own characteristics, like how health conscious they are or how sick they are, right? And that leads us to our clicker question, which is the following. I want people to think through selection into treatment. This is like a very wordy question, but I want it to be accurate. So this is the question. Remember, in 1998 at baseline for group 1, we collected infection data. We know whether you're sick. And then we know some of those people went on to get treated, and some of them went on not to get treated. Do you think that the people who ended up getting treated were sicker at baseline in terms of having more worm infections, or were the people who ended up being untreated sicker at baseline? And the two different stories are, maybe if I'm really, really sick, I make sure to get the drug. And that would mean the treated are really the sicker ones, and the untreated are kind of the healthier ones. So like, I don't need to get the drug. The opposite goes back to our story about maybe socioeconomic status differences or whatnot. Maybe the kids in the poorer families with the parents that are sort of less aware about health never got the parental consent to get treated, whereas the kids from the better off families where the parents were on the ball made sure their kid got treated. In that case, the kids who ended up getting treated might have been healthier at baseline. Okay, so option A is the people who end up getting treated have a higher baseline infection. In other words, the sicker people are getting treated. Option B is actually the people who get treated are healthier at baseline, and option C is they look kind of the same. So let's just go for another 10 seconds. Anybody else clicking in? Okay, I'll just go to 2 minutes. Okay, so it's pretty interesting. You guys were, kind of pretty evenly split. So most people said, or the largest number said, kind of even. A bunch thought that the people who ended up getting treated were actually going to be a little bit healthier. They were going to kind of select in that way, but a lot thought that maybe sicker people ended up getting treated. So what does it look like? Well, it is actually true that the people who ended up getting treated, if we look at their baseline infection, they were a little bit healthier. But it's pretty similar, actually, 39 to 41. And we talk about it in the paper. I'm not presenting here. If you look at things like latrine ownership, livestock ownership, all those other characteristics, the people who get treated and the people who are untreated look remarkably similar. Surprisingly so. You might have thought people would very systematically select into treatment based on their characteristics, but at least based on family socioeconomic characteristics, their own deworming, their own worm infection status, they look pretty much the same. So it's not random. It's not an experiment. There might be unobservables that we haven't measured that differ between these groups, but they look pretty similar. Yeah.
I don't know the cultural, were there religious differences or anything that
Yeah. Yeah. It's an interesting question. There are certain people who more than others are very wary about participating in health programs by NGOs or even the government of Kenya. And one of the common issues is that maybe there's sort of some agenda the NGO has. It's not really deworming, but these pills will do something else. And throughout the time this NGO had worked in Kenya, these kinds of rumors would occasionally pop up in communities when the NGO had sort of clarified exactly what they were doing. And that's part of why I think take-up isn't 100%. Part of it is people weren't on the ball, but part of it could be this resistance to participating in a program that people don't fully understand. So that could be one of the unobservables here. So even if people are balanced based on livestock ownership, maybe they do differ on these other dimensions. So this is non-random for sure. Was a hand up in the back or no? But anyway, it's pretty interesting to look at this. And so to the extent that this gives us a little more confidence that these groups are comparable, at least broadly comparable in terms of health, then there's a way to actually interpret that difference as an externality. To say that if I'm in a deworming treatment school, but I don't get treated, I kind of benefit a lot. I would have been at 52 in expectation, and I'm at 34%. I don't get all the way down to 24%. But I'm getting reinfected a lot less because 3/4 of the kids in my community no longer are passing worm infections onto me, and over time the worms in my body are basically dying off. So I'm getting a bit healthier. That's the way to interpret this in terms of an externality, if we kind of believe these guys are broadly similar. So in the 2004 paper, we sort of downplay these estimates because they're not based on the experiment. At the same time, in our own thinking, when we've looked at all the data we have, all these dozens of characteristics, plus their baseline health looking similar, we feel like this is pretty strong suggested evidence, at least, that there probably are within school externalities. Okay, so if we believe these externalities, the implications are clear. By taking deworming drugs, kids in the treatment schools aren't just benefiting themselves, they're benefiting the kids that are untreated in their own schools. And that means that they're not taking that into account. Too few people are taking deworming. They're only considering the benefits themselves, potentially, and not the broader benefit of their action. And this is the rationale, the kind of standard public finance rationale for subsidies. There's kids being untreated in my school. If only I would get treated, I benefit myself and dozens of these kids through lower reinfection. So you have to incentivize people to do what's good overall. Now, I want to go back to these estimates just in the last 3 or 4 minutes and point out a fact. Before our study, now the results are changing a bit with some of the newer studies. Before our study, there have been 4 or 5 randomized experiments, and this is the way they were designed. They were deworming experiments. They randomly picked half the kids in school, gave them deworming drugs. The control group got a sugar pill, so there was no placebo effect. Everybody was taking the pill. Some were getting deworming, some were getting a sugar pill. And they tended to find these kind of positive but kind of small effects of deworming. How can our study shed light on why that might be the case? Yeah.
Well, there are 2 problems. I think first is Dr. Cooper does not have education.
Yeah.
What you guys found out happens results on the
Right, the registers, huh?
And the second problem is like all these personalities that
Yeah, it really feels like we're kind of missing the boat on understanding deworming treatment if there are big within school externalities. Because what we did when we went back to these studies, which was very interesting, is we looked at the time pattern in health measures and educational measures for the control groups in those studies. What do you think health status looked like for the control group in those studies over time, in all the previous studies? They were just getting better in all those other groups. Now, in any one study, you would get back to this point, well, maybe there was just some time effect over time. We don't want to put too much stock in it. But if in study after study, the control groups were getting better over time, that's suggestive evidence for these kinds of externalities as well. So going back to this study, that difference is sort of roughly, if we believe that, that the people who took the drugs were comparable to those who didn't, that would be the kind of estimate the previous studies would say is the impact of deworming. But what we're saying the real impact was that 27% versus 52%. We're saying the real effect was 25 percentage points, and they were saying 10 percentage points. That's a huge difference. And it would lead you to say, well, maybe deworming's a small thing, as opposed to being something important. So that's a methodological point. And I think it illustrates why the design of an experiment, if you're doing an impact evaluation, is so important. And this is like the punchline of the lecture today, and we're going to continue on next time. If you are designing an experiment where you think there might be externalities, you need to do higher than individual level randomization. You have to do what's called a cluster randomized design, school level, community level, so that these externalities are picked up within the treatment group. And you're not like blatantly cross-contaminating treatment and control. Okay, let's continue on Tuesday.